How is everybody today? Today we're going to be working with solving equations where variables are on both sides of the equation. To solve an equation when you have variables on both sides, that is going to be the first step that you take care of. So in other words, I see that I have a 6x plus 3 on one side and 8x minus 21 on the other side. That means that I have variables on both sides of the equation, so on either side of the equal sign. When that is the case, that's going to be the first thing that I sort of combine. Now keep in mind that if I had 6x plus 8x plus 3 equals negative 21 on the same side of the equation, the first thing I would want to do is to combine like terms. But as you can see in this problem, the variables are not on the same side of the equation. This equal sign acts as a barrier. So when that is the case, then instead of just combining them, we're going to use opposite operations. You could either get rid of the 8x or you could get rid of the 6x. I choose to work the right side of the equation when I can. And to get rid of 8x, I'm going to subtract 8x. Whatever I do on the right, then I also have to do on the left. So I end up with what? Negative 2x plus 3, keep your equal signs lined up, is equal to negative 21. Now, with that one step, I have a two-step equation. To solve this equation, I'm going to subtract 3 on both sides to isolate negative 2x. And then because this is multiplication, I'm going to divide through by the coefficient of negative 2. Multiplication and division are opposite operations, and I'll end up with x is equal to 12. If I want to make sure that my answer is correct, then I can go back and substitute in 12 for my original x. And this tells me that each side should be equal to one another. So on this side, I have 72 plus 3, or 75. And on this side, I have 8 times 12, which is 96. And 96 minus 21, ding, 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 that equals 75. So that will absolutely work. I'm going to circle my answer before I go to the next problem. Once again, I see that I have variables on both sides of the equation, but there's nothing else I can simplify. So as I'm looking at this problem, nothing I can simplify. 6d plus 14, I cannot put together negative 7 and negative d, so I'm going to combine the d's. To get the d's together, I'm going to use opposite operation. This is negative, so I want to add d, because really what I'm trying to do is to make that a 0 or get the negative 7 by itself. Over here, I'm going to go ahead and I know that it's a 1, so I want to make sure that I include that. That's a 1, that's a 1, so that I don't forget to add 1d to 6d. Line up your equal signs, negative 7. Now, my friends, we have a two-step equation. To get rid of the 14 or isolate the 70, we're going to subtract 14. Whatever I do on the left, I do on the right. Divide through by your coefficient of 7. And we end up with d is equal to negative 3. And you can go back and substitute in negative 3, and that would give you equality on the left and on the right. In this case, we have a decimal. Before you try to eliminate the decimal, you might want to just distribute it and see if you get rid of the decimal by distributing. So on the left, in my mind, I'm saying to myself, is there anything I can do to simplify the left? Well, no, I can't put negative 3n minus 8 together. And on the right, I have I'm going to use the distributive property because I have parentheses. So I want to distribute 5 to 0.8, and I want to distribute 5 to 2. So on the left side, I'm just going to use 0.3n minus 8. And then on the right, 5 times 0.8 is just going to give me 4. So by distributing the 5, then I end up with an integer. 5 times 2 then is 10. Because I have a decimal, then I can go through and multiply the equation by 10. So in other words, if I multiply 0.3 times 10, that's going to move the decimal one place to the right. But if I do that, then I'm going to do that throughout. So we can't just multiply the 0.3 times 10. We have to multiply all of the parts by 10 to get rid of the decimal. From here, now I'm kind of starting from square one. I've got 3n on the left and 40n on the right. You can subtract either one. I'm trying to work the right side. That's what I do. Next step, we're going to isolate the negative 337n, so we get rid of negative 80 by adding 80 to both sides. And I ended up with a decimal, 4.865. And it is negative because it's a positive divided through by a negative. It didn't say what to round it to, so I just chose to round to the thousandths place. On this problem, I have the distributive property on both sides, so I want to simplify. To simplify, I'm going to multiply 8 by 2, and I'm going to multiply 8 by negative 3. On the right, multiply 4 times 4. Don't forget to bring over the f, and then 4 times a negative 8 is negative 32. Now, we can simplify. I notice that I have a 16f on the left and a 16f on the right. Remember, when I have variables on both sides, I have to get rid of one of them. So I'm just going to, in my mind, think I'm getting rid of the one on the right. Whatever I do on the right, I do on the left. End up with negative 24 is equal to negative 32. Well, is that a true statement? Not so much, because negative 24 is not equal to negative 32, and it's a false statement, then the answer is no solution. If I get down to this point and the left side is equal to the right side, then that means that it's identity, or I have an infinite amount of solutions. So can I simplify anything on the left? No. 4b minus 1, I can't combine those terms. They are not alike. But I can combine terms on the right. And what I can combine on the right is a negative 4 and a positive 3. I'm able to do that as long as they're on the same side of the equation. Negative 4 plus 3 is negative 1 plus 4b. Now I have variables on both sides, so because I have variables on both sides, I'm going to get rid of this one. To get rid of a positive 4b, I'm going to subtract 4b. Make sure I do it on both sides, and this is what I was referring to in the last example. I ended up with negative 1 equal negative 1. Is that a true statement? Yep, true. Because it's true, then that means that it's identity or many solutions. So what that tells me then is no matter what number I plug in for b, if it solves it on the left, then it's going to be equal to it on the right. I hope you enjoyed your lesson on variables on both sides.